Welcome, ladies and gentlemen. My name is Mr. McLogan, and this is Open Live Q&A, week number, oh no, come on. There you go. Week number 141. I hope you guys are doing well tonight, and I look forward to having another great stream with you guys. And hey, Bruno, hey, Just Hufflepuff, Mr. Sarcastic, Addison Carr, Nick, good to have you on. Bruno, Sleepy, good to have you guys on. It has been a good week, and I hope you guys are ready and excited for another week. I do have a couple questions, math questions, that I'll be answering tonight, but also just a throw out there for all of you guys that may still have a question that or any kind of like math questions. You guys can always go ahead and throw them into the chat. I have the chat pulled up right now, so I'm happy to be able to answer them. Anything like around math or whatever else. But if you do have a specific math question that you'd like me to answer, then I would recommend then you go to brianmclogan.com/Q&A, because that is where I take all the math questions. So if you have anything that you're working on, you have a test, maybe a quiz, homework coming up this week, I will try to see what I can get done for you guys this week or for during this live stream. And then I am live every single Sunday night at 9 p.m. So if this is your first live stream, welcome. Happy to have you on. And yeah, that's what I'm doing. I didn't have anything planned to cover, or at least like a main topic. I just wanted to kind of do like a little open live stream. I do have a whole bunch of things actually I wanted to cover with you guys, or like upcoming topics, going on that I'll be making eventually into videos. But yeah, for this live stream, I was like, what? I'm going to go live and answer some kind of questions. So hopefully you guys add on. Hello, Extrude. I'm never extended for Monday. Yeah, I know. I definitely. Hazel, you got an exam tomorrow. Wow. Best of luck. Hope you're ready. Nick, you got 107 on my pre-calc test. That is awesome. Congratulations. I'm assuming there was a couple extra credit questions that you're probably able to knock out. So that is pretty sweet. You're helpful in one of your old videos, I think years ago. Well, awesome. So happy to, it's kind of weird how like the live streams will kind of like connect in on from there. And you see like an old video from years and years ago and join in. So Burke says, what do you think is the best tip for studying? I mean, I would recommend doing my cheat sheet. I mean, I love doing the absolute cheat sheet. So, cheat sheet is basically just taking all the information you have, putting it down on a sheet of paper, and then you can just, then you can basically just use that sheet of paper consistently like throughout the whole year. So I would definitely recommend doing a cheat sheet if you have not already created one. Definitely start creating it like for every single chapter. And then even if you haven't created one up to this point, like start going back, like just, from now on, like create a cheat sheet for all of those chapters and everything else. And yeah, you can, you can use it for the rest of the year. I think it's pretty powerful. What is your favorite number? So growing up, I used to really, really like 33 because of Jose Canseco. I really liked Jose Canseco as a baseball player. And then when I started playing sports, though, I started to get attached to 21 for whatever reason. And then, yeah, I don't know, but like 5, 21, 33. I don't know. There's some good ones that I've had. Hey, FLVS, liking it. No, Rana, I don't think I'm doing any giveaways. But yeah, I was trying to do. I am basically what I decided to kind of do as far as like on the giveaways is I'm just going to do the long-term tutoring because I like having multiple sessions with the tutoring session rather than just like a one-off session. It didn't really. It takes a while to like get everything scheduled as far as I'm from there. So what I'd like to do is kind of stitch together multiple sessions. And that's what I am kind of been working on or doing right now with a couple students. So that's probably what I'm going to be doing. I'm not saying I'm against doing the, more giveaways in the future, but yeah, that's probably where I like to kind of focus because I like kind of building a little bit more of a relationship with one or more tutoring session from on there. When will I learn trig? Last lesson it took me transformations of functions. I'm in pre-calculus. Okay. Yeah. So typically you're going to do transformation of functions. Typically in a pre-calculus class, you're going to get into You do functions first, then you're going to get into like polynomials and rational functions. And then in my class, we would go right into trig. But also when I took pre-calculus or other textbooks, also we'll get into, logarithms and exponential, and then usually trig. So it should be coming up, too bad from on there. I'll definitely, as of right now, I'm actually like completely overwhelmed. I just don't have any time for them in there, but, I think, I think what we're going to do is like probably like every quarter, I'll probably like still be accepting, clients, not really clients. I mean, it's not charging you anything, but, I'll kind of be looking in for like different things. Cause I know like everybody throughout the year has different needs, right? At the beginning of the year, some people need tutoring and then they're good. Right. And then maybe some other people are like, holy crap, like I'm really struggling with class. I need help, and maybe it might not come till like end of the year, or like after return from winter break. So yeah, I'm definitely looking forward to I think I'll be opening up things. I'll be like pushing it a little bit more like kind of throughout the year because it is fun. I really actually do enjoy getting to know people on like kind of a one-to-one basis. And, rather than just like trying to fit as much questions as we possibly can in like 30 minutes, which is fun, but I don't think it brings as much value to myself and others than that it possibly could. I do not know. I do not remember, but that's a good question. One of them. All right. So, I'm just gonna actually get into the questions, or at least the math questions. And then if you guys have any questions that you want to cover for me, I do have 2 math questions I want to get to. And then if you guys have any questions, feel free to like add them in onto the chat and I will go up from on there. All right. So one of the first questions I came in through is I need help converting a standard form into Vertex form. So I'm just going to get right into this one. We're getting this one quick. And so the main thing, I forgot I checked that one off. So I think the main thing I want everybody to understand when you're trying to convert from standard form to Vertex form, this is going to be done by using completing the square. Okay. So in this case, what we have is we have a function. All right. Let me change this to this one. Okay. So we have a function f(x). And let's see, it's ax squared plus bx plus c. Okay. And what we're going to do is we're going to put this in what we call our vertex form, which is a times x minus h quantity squared plus k. Okay. Now there's a couple things I want you to understand. The cool thing about this is from here to here, this has a binomial square. There's only one x, right? So what we need to do is we need to create a perfect square trinomial. Now, the thing that I always I think we can always teach this of like, do this, then do this, then do this, right? But what happens? Most students forget the whole reason of what they're doing, why they're doing it, and how to do it. So the main thing I want you to understand is or the beauty of completing the square is understanding perfect square trinomials, right? So let's just kind of go through a general one like x squared plus 6x plus 9, okay? This is a perfect square trinomial. What 2 numbers multiply to give you 9, add to give you 6? Hopefully you recognize, hey, that is a 3 and a 3, right? So x plus 3 times an x plus 3, which is the exact same number, right? So which can be written as an x plus 3 quantity squared. Again, that relationship of going from standard form to a binomial squared is exactly what we're looking to trying to achieve, right? We're trying to create this perfect square trinomial because then it can be factored onto a binomial squared, which is going to put us into this form. So if you look at this equation, f of x equals a 3x squared plus 5x minus 4. Is that the same thing as like this? Is that a perfect square trinomial? And unfortunately, no. I kind of wrote that really fast, so let me just rewrite it a little bit slower, make it nice, a little bit neater. So what we need to do then is we need to create a perfect square trinomial with that information. So I have an f of x equals, let's say a 3x squared plus 5x, there you go, minus 4. Okay, so how do we create a perfect square trinomial? Well, the first thing we want to remember is when we're trying to create a perfect square trinomial, we cannot have a number in front of our x, right? So actually what we need to do is factor that number out. Now, I'm assuming that's probably one of the reasons where this problem gets kind of confusing because there's a couple different ways to go about this. The way that I'm going to teach it this way is I'm just going to factor out the first 2 terms. I'm not going to worry about the constant. I'm just going to try to create a perfect square trinomial with the x's, okay? So when I factor out a 3, what I need to do is I'm getting rid of the 3, right? So I'm basically dividing out a 3 from the first two terms. That's going to leave me with a x squared plus a 5/3 x minus 4. All right. So again, notice I didn't do anything with the 4. I just factored the 3 out of there. Now, this is what I'm going to want to do is create my perfect square trinomial. Now, the thing I want you to understand about this perfect square trinomial is notice the relationship between the 6, which is our middle term, and our constant, right? So what happens is how do you go from 6 to 9? Like, how can I do that? And you might be like, well, you add 3. Well, yeah, you could add 3, but that's not going to work for all, that doesn't work for all numbers. Like, how can I consistently go from whatever my middle term is to find my last term, right? And that's going to create always a perfect square trinomial. And it just can't be add 3, right? You could do this with like 4s or 5s. Like, what is it we can do to go from given our middle term to find that last term? And what we do is we call that number like c, okay? So we say like x squared plus a 5/3 x plus c minus 4. So how do we obtain this value c? How do we get that? Well, what you're simply going to do, or what the rule is, like c is equal to a b divided by 2 quantity squared. That's how you can always find the c. So in this case, what I'm simply going to do is I'm going to take a 5/3 divided by 2 and then quantity squared. Well, what is 5/3 divided by 2? Well, hopefully you recognize here, that is going to be a 5/6 squared, which is going to be a 25/36. So therefore I have a 3 equals a x squared plus a 5/3 plus, and this is going to be a 25/36. Okay, now this is where things start to get a little confusing, because what I want you to understand is when I factored out the 3, all right, when I factor out the 3 here, I didn't really change anything on this side of the equation. I just factored out the 3. However, when I add a 25/36 here on this right-hand side, you just can't randomly add a number, right? So whatever you add a number, if you want to keep this equation pure, you're going to have to subtract the number. So I need to subtract a 25/36. But things just got to leave in a little bit worse, because I am actually not adding a 35 or a 25/36. What I'm doing is, when you look at this parenthesis over here, no, where's that going to go? Okay, that's going to go to the 5. What's happened, what I want, oh, shoot. Okay, let me just rewrite this. So that's a 25. So it's going to be minus a 4. That's going to be minus a 25/36. So what I want you to understand is, because of distributive property, there's a 3 that's being multiplied by the 25/36, right? The 3 is actually multiplied by everything inside that expression. So over here, I actually need to multiply this by a 3 as well. So therefore, now this is going to become a perfect square trinomial, okay? Just like we did over here, like why was this so important? Again, I can go from perfect square trinomial, I can go from a binomial squared down to, or I'm sorry, a perfect square trinomial down to a binomial squared. So the confusing thing is, well, how do you factor that? How do you factor that down? And I did forget an x. Let me put that x there. So the cool thing is, if you want to find that h, all h is b divided by 2. Okay, now I'm going to say plus or minus, because again, if we have a positive, we want to make sure our h is positive. If our middle term is negative, then we want our h to be negative. So what was our b divided by 2? Our b divided by 2 was 5/6. So yeah, you could try to like factor this and think about it, but again, like here, it's really easy. X plus a 5/6. Now let's go and check our work, okay? So, and then again, it's a 5/6 squared. 5 times 6 times 5, or 5 times 6 is going to be 25/36. That is good. And hello, Nee. And then 5 plus 5/6 plus 5/6 is going to be a 10/6, right? Which again, divided by 2 on top and the bottom is going to be a 5/3. So it works out. Now over here, we have some work to do. So I have a minus a 4. And then over here, I can divide this out. I can divide a 3 into the top and bottom. So that's going to be a 1. Divide a 3 into the denominator. That'd be that's not going to be a 9. What am I doing? That's going to be a 12, right? So 1/12. That's a 1/12, right? So it's a minus 4 minus a 25/12. Divided 3 in the top and the bottom. Okay, so now I just got to combine these two, right? And hey, Jan and K Carl. So then what I'll do is I'll put a 1 over here, right? And then basically I need to multiply that by a 12/12. So it's like, because I got to get common denominators. Man, this is a good problem. 3 times an x plus a 5/6 quantity squared. And then this is going to be minus a 12/12 minus a 25/12. Now they have common denominators, so now I can go and subtract them. If you owe me $12 and you borrow $25 more, you now owe me a $37, right? And again, that's all going to be divided by 12. So this is 3 times a x plus a 5 over 6, quantity squared minus a 37 over 12, assuming I didn't make any mistakes. My vertex now is going to be a negative 5 over 6, comma, a 37, negative 37 over a 12. Whew, okay. Now it's going to get into another quadratic, but this one's going to be a inequality. So this one says in exercise 13 through 34, solve the inequality. Solve the inequality, then graph the solution. Well, hey, Andrew, so happy to be able to help you out. Then graph the solution set. All right, so whenever you're doing an inequality, what I always like to do is we want to be able to kind of find like the kind of like test points. What we're going to do is like kind of find the intervals. So what I want you to do here is we're just going to take this graph and we're going to set it equal to 0. We're going to find the zeros. Okay, so 9x, and we're just going to set it equal to 0. So in this case, I can factor out a 3x, and that's going to leave me with an x minus a 3 equals 0. So 3x equals 0, and x minus 3 is equal to 0. Therefore, x is equal to 0, and x is equal to a 3. Okay, so those are going to be the zeros of the graph, right? Basically where the graph is going to cross the x-axis. So I'll say 0, and I will say a 3. Then now what we need to do is go ahead and use or check a test point to kind of see like, is it going to be positive or negative? Because when we plug in a value between like these values here, if that value is going to be positive, then we can say the solution set is going to be positive. Like that's going to make that true. So let's go ahead and pick some points. Let's do -1. Let's do +1, and then let's do 4. And let's go ahead and check it out, see what like works. Now, again, I'm going to go back now and plug these into this inequality. So if I do a 3 times -1, quantity squared, notice I'm using parentheses. I think it's really, really important to make sure you're using parentheses. So therefore you don't make that mistake when you are simplifying it. So that's going to be 3 times -1, greater than or equal to 0. All right, so a -1 squared is going to be a +1. So that's going to be 3 plus 9 greater than or equal to 0. So that's going to be a 12 is greater than or equal to 0. So we can say -1 is going to be a positive, right? So sometimes we kind of look at this like that. Let's go and check out a 1. 3 times 1 quantity squared minus a 9 times 1 greater than or equal to 0. That's going to be a 3 minus a 9, which is going to be a what? -6 is greater than or equal to 0, which is not true. So that is going to be a negative, and then let's go and check out a 4. So 3 times a 4, quantity squared minus 9 times 4. Greater than or equal to 0. So that's going to be a 16. So 16 times 12, or 16, 32. So that's going to be 48. Minus a 36, greater than or equal to 0. And you can say, hey, that's going to work. That's going to be 12 greater than or equal to 0. So that's positive. All right. Now, so therefore, hopefully you can recognize then that my, then graph the solution set. So hopefully you can recognize here that this graph is going to be positive from -infinity, right? It's going to keep on going all the way to 0. And then union, all values from 0 to infinity. Okay. I'm sorry, not 0, 3. Because there's nothing happens from 0 to 3, right? So it's going to be 3 to infinity. Now, another way to kind of look at this, or what I always kind of like tell students is like, this is fine. And this is very helpful also when you get to calculus. But I think also like in the fact of like, if you understand what this graph looks like, you should be able to graph this, right? So if you understand what the y-intercepts are, right? As we talked about a 3x times x minus 3, you could also graph this, right? We know that the a is going to be positive, so the graph is going to open up. So what I can do here is just say, I can do 0 and then 1, 2, 3, right? Now, since a is positive, we know the graph is going to open up. And therefore, you could see that the graph is going to look something like this. So therefore, you can see, yeah, from -infinity to 0, the graph is positive. And then from 3 to infinity, the graph is also positive. And hey, Lethal Jim, your videos about A and B and piecewise functions really help me. Well, awesome. So happy to be able to help you out. All right, guys, I am actually going to call this live stream a little early, unless you guys have any questions back in for me. But yeah, it's been a long weekend for me on there. Thanks for your help. I've been using your videos throughout high school every day after school so I could get where I'm at right now. Just saying thanks. Well, you're very welcome. So happy to be able to help you out. And then, but yeah, it was my daughter's birthday this weekend. So we had a big week. And then I'm actually, I got a lot of videos are coming out, working on a lot more stuff. So, yeah, definitely work for it. So I think we're going to cut this stream a little bit early for you guys. But yeah, if you guys do have any math questions, feel free again, guys, just go to brianmcclogan.com/Q&A. And then I'll be here back again next Sunday night to answer your questions. All right, guys, have a good night. Cheers.